Hi, this is Mike Carter with Carter Custom Knives. One question I get a lot from people who are interested in maybe making a knife is, what do I need to get started? What tools do I need to make a knife? And the simple answer is very little. I mean, you can make a knife with a piece of steel and a file. And in some cases they're one and the same, because some people make some excellent knives out of old files. So, I mean, it just depends on how much time and work you want to put into it. But yeah, I can take this piece of steel and maybe with a hacksaw cut it to the shape I want, file my edges on it. You know, with just very little hand tools, you can make a good knife. A good friend of mine, Bud Payton, he made this knife out of an old file. Does it all by hand, grinds his blades by hand with a file, uses very little in the way of power tools, and makes an excellent knife. People who are forging knives, you know, one thing, almost every old bladesmith has made a knife or two out of a railroad spike. And it makes a neat novelty item. Truth is, I mean, you can get an edge on this, but truth is, a railroad spike doesn't have enough carbon in it to make a really good blade. And that's kind of a misnomer I'll touch on here. A lot of people do see that on the end of a railroad spike it'll be stamped HC for high carbon. That's true, but the problem is what the railroad considers high carbon and what a blade maker considers high carbon are two very different things. Railroads actually specify for the manufacturers of their spikes exactly, you know, how they can be made. And their specs, something like, I think for a high carbon blade, I think it's something like they cannot contain more than 0.2% carbon. Now, from a knife maker standpoint, that is very, very low. A knife maker generally wants anywhere from about 0.5% to 1.5% carbon. So this, from a knife maker standpoint, would be considered a mild steel. And the reason that the railroad wants it that way is the more carbon you put in the blade, the more brittle it gets. The railroad wants a spike to bend rather than break. A bent spike will still hold a rail, a broken spike won't. So they're very particular about, for their straight line sections of track, they use an even lower carbon, and for curves they use a little higher carbon. But again, what they call high carbon is not what we would call high carbon. And you know, you get into methods of making knives. You know, the factories generally just stamp their knife blades out of a sheet of steel. Someone who forges knives, you know, they're taking whatever steel they've got and they're actually heating it up red hot to where you can move the metal with a hammer, and they're beating it into the shape that they want. And people like me, I do my knives by stock removal, which in other words, I buy a bar of steel that is the type of steel that I want. You know, I get it straight from the manufacturer, so I know exactly what the contents of the steel is, what the recipe is. It's very predictable in how it's going to perform. Know exactly what the proper heat treating methods are. And I can buy it in the width and the thickness that I want, or sometimes I'll buy it in wider widths and cut it down. But this is just an example. You know, I buy a bar of steel like this, I trace my pattern on it, or draw whatever I want the shape to be, and then I cut it out. And I can cut it out with a hacksaw. For a long time I cut them out with an angle grinder with a cutoff wheel on it, and just roughly cut the shape. And as I moved up and actually started trying to make a living at this, again, anything that you can do to speed things up a little bit, make it a little easier is better. I bought a Wilton metal cutting bandsaw. And this might look like your ordinary bandsaw you'd see at Home Depot, but it's really not. Metal cutting bandsaw has a couple of key characteristics that are different from a wood saw. Number one, they run much slower. And if you see the blade on this, it's running very slow. In fact, this will run anywhere from 39 up to 3,000 square feet per minute. It does have a transmission and a series of pulleys where I can adjust the speed, but generally you want to run them very slow. Also, you've got wheels in here with special rubber coatings on them that stand up to the heat that the blade will generate from cutting steel. And your blades are going to be different. I use a bimetal blade where the teeth are actually made of one type of metal, a harder metal, and the back is made of another type of metal that's more flexible. So you get that hard cutting edge, but yet the blade's flexible enough that it's not going to break under stress and heat. So, before you cut it out, you have to know what you want to cut out. And again, everybody has their own methods of doing this. I always draw a design on my computer. And most of what I do is custom made to order. So I'll draw the design and generally email it to the customer and say, okay, are we talking about the same thing here? Is this what you had in mind? Maybe he'll make some changes, maybe I'll make some changes. We'll make the revisions on the computer, and when we're done, I'll print out a full-size print of it. And this serves as my template. I can actually cut this out, lay it on a piece of steel, trace around it, and I've got my blade shape. Now, if it's one that has become somewhat popular, and I might make a bunch of these blades, I'll make a plastic template. And as you can see, that's just this blade cut out in a piece of plastic. And now I can just lay that on a piece of steel, trace around it, cut it out, drill my holes for handle pins. Do things like this will have a guard, so I'll cut little shoulders on it, and that's my blade. In fact, here's one of these blades in progress for an order I'm working on right now. So again, you can see I just took that template, laid it on a piece of steel, cut it out, and I start grinding my blade, drilling my holes. Made a slot here where a stud's going to be to hold an end cap onto it, and do my heat treatment and everything. But so again, a metal cutting bandsaw really speeds things up. You don't have to have it. You can cut them out with a hacksaw, angle grinder. This just makes it faster and easier. Now, once I get a blade rough cut, still going to be rough around the edges, needs a little cleanup. Then I'll go to my disc sander. Once I have a blade cut out, my next step is to profile the blade. And that's just to clean up the edges, make good smooth curves. And I generally do this on a disc sander. I can just lay this against the wheel, roll that edge back and forth, go along the back, do my handle curves, almost anything except for these little finger guards. I'll have to use a different method for that. And if you've got any pitting or anything in the surface of the blade, you can also clean that up just running it on the disc. And some people actually even grind their blades on a disc. So that's another very good tool to have in the shop. There's other ways to do it by hand with sandpaper or whatnot, but disc sanders are very handy, and generally they're very cheap. This one I have here is a little Delta 1-inch belt grinder. Comes with the disc sander built into it, and I picked this up at a home store for $100, and I've used it for years. When I first started out, for about the first 3 years, I ground my blades on this little jet multi-tool. And this is a bench grinder that's been outfitted with a extended arm here, and it's got a 3.5 inch wheel on the end. It's got a platen here. It's got a stone on this side, and it's also got a disc sander here. And for about the first 3 years, I actually ground my blades on this little 3-inch wheel right here. So again, this is another very good tool, very versatile. I've had this one for years. I think with this attachment on it here, what they call the multi-tool attachment, I think these things run around $400. So again, not a whole lot of money, but can be a very versatile tool. And just continuing my little messy little shop here, I also have another belt grinder. I use this one more for flattening out my handle materials, make sure I got a good flat side to meet the tang. But you notice this one also has a little disc grinder on it. So 3 machines here I bought happen to have a disc on them, and I generally just keep all 3 of them set up with different grit sandpaper. So if I need to grind something on a disc, a really coarse grit, I can go here, maybe a finer grit, and then a real fine grit on the third one. So, and again, you know, most of these machines are $200, $300, $400. Not necessary, just another thing that makes it a little easier. But again, primarily I use this for handle material. If I got a block of wood, I need to make sure I get it good and flat on one side to meet where it mounts up to the tang. I can just put it on here and flatten it out. You'll also notice that I have a dust collection system here that I made myself. I've got some receptacles here. This. And some piping. And it all runs up to a little cheap Harbor Freight dust collection unit. And my dust collection runs up to a little cheap dust collecting unit that I bought from Harbor Freight. You also might notice I've got an old furnace motor here that is going to be my better dust collection system. When I get it finished up, I'm going to connect everything to that and have a much more powerful draw. If you don't have a dust collection system, be sure you wear a respirator. Some of these woods can be toxic. You can have allergic reactions to them. And even grinding metal or brass, you just don't want to get those fine particles of that in your lungs. Eye protection and a respirator are essential tools for a knife making shop. Okay, so once you get your blade ground and profiled, and you've got your center line marked for your edge, and you draw your grind lines on here, now you got to grind the blade. And there's a number of ways you can do this. As I said, you can do it with a file. It takes a long time, just a lot of slow, meticulous work, but you can do a fine job with that. For the first 2 or 3 years that I made knives, I used this little jet multi-tool grinder. It's got a 3.5 inch wheel on it, and it did a fine job, especially on some of these smaller blades. But the smaller the wheel, I do a lot of hollow grinds, and so it makes a pretty short, narrow hollow grind. It was good. It was what I could afford, and it worked fine for a while. But some people will actually grind their blades on the disc sander. And again, this will work. And some people have a disc sander that's horizontal, and they can grind their blades on a flat surface that way. It works. most knife makers eventually graduate to a better grinder. This is my Bader 3. It's a benchtop, designed to be a benchtop model, but as you can see, I've set it on the floor and built a little box for it. And I like to sit while I'm grinding, and I have this little swivel stool. Actually got a motorcycle seat on it. But this is the way Gil Hibben taught me to grind, where I can run that blade across the wheel, bracing my elbows on my knees or on my thighs, and just swivel back and forth to draw that blade across the wheel. And you know, this uses a bigger belt. This is a 72-inch belt, which tends to last longer, run a little cooler. You know, when you get into doing big blades, bigger hollow grinds, you know, it gives me a larger radius to get these good wide hollow grinds. And you know, another advantage of something like this, you can get different size wheels. It's a 10-inch wheel it's on here right now. I've got an 8-inch wheel I can put on, changes very easily. It's easy to change if I want to go to a fork tip. Just that easily, I can change it to a fork tip wheel, and this lets me get into places like this, doing these finger grooves, like this. And there's a variety of wheels that are available, anywhere from about a ½ inch up to an inch, and they're pretty quick and easy to change out. So you know, it just gives you a lot of versatility to grind your blades. Now, of course, once you've got a blade ground, you have to heat treat it. And you know, when I buy my steel, my blade steel, I get it in the annealed state, so it's relatively soft. You can cut it and drill it. After you heat treat it, if it's properly heat treated, you know, it's going to be as hard as your drill bits are, so you can't drill it or do anything. You can grind it some, but you can't drill it or cut it very well after it's heat treated. So normally I will grind them to about a 220 grit finish, then I'll do my heat treating. After heat treating, you will have a scale, some decarburization on the knife. Kind of gives it that dull gray finish, and so then I'll grind it again, and I'll start back at 220 grit and proceed. If I'm going to do a mirror polish, I'll do 220 grit, 400 grit, 600, 800, 1000 grit, and then I'll go to the buffer and start polishing it. So you know, when you get into doing that type of thing, you will find that you're using a lot of belts. When you get into this level of knife making, you'll find that you can go through a lot of belts, and the belts aren't cheap. You know, you can pay anywhere from about $6 to $12 depending on what they are. Continuing with the tools that you need or can use. You really need a good vise. There's going to be numerous things where you need that vise to hold your knife while you work on it in one way or another. This is a neat little device. A friend of mine made this one for me, but you can buy them commercially. This little vise has some rubber jaws in here, and I can clamp down on it. And it's for finishing handles. I can take my sandpaper, work that handle, rotate it any position I need, and finish that handle out. Now also here I have a variety of files and punches and you know, hammers and a lot of different things that you know, you need to do for some little finish work and touch up. One tool that I use a lot is my little Dremel tool, and I have this one mounted on a flex shaft. The motor is actually down here, but I've got a flex shaft, and I find this is you know, just easier to use for me. Depending on what you're doing, you can hold it like a pencil. But you know, I've got a sanding drum on here that's good for cleaning up places like the finger grooves on a knife, or smoothing out a guard. I also use cut-off wheels for knife handle pins and things like that. These do a great job. Over here I've got my wood cutting bandsaw, and unlike the metal cutting bandsaw, you can see this one runs much faster. But you know, you need this for cutting your handle materials, and you can get different width blades, different tooth designs, whether you're just doing coarse cuts on big thick pieces or you're really cutting an outline of a piece. Advantage to a bandsaw over other types of saws is it will allow you to cut curves, so that can come in real handy when cutting knife handles. And you know, this is something I picked this up on sale for I think $125. I've used it for years. Again, not a terribly expensive piece, but really useful in a knife shop. This is my buffer, and I bought this one from a company called Caswell Plating. I especially like this machine because of the long shafts on it. So I've got wheels at each end. You know, I use a harder wheel and a softer wheel, and when I change out finishing a handle or something, I might switch one of these out for a loose cotton wheel. The long shafts are very useful, especially if you're doing big knives. It just allows you to get out here and work that wheel without the motor being in your way. If you had a little short shaft and you're trying to buff that long grind, your knife starts hitting the motor and it doesn't work as well. So these long shafts are really useful. But, this one now this particular machine runs at 1100 RPMs, which I think is about right. Most of the grinders and buffers you find in you know, Harbor Freight type stores, they're going to run 3400 RPM, and that's really fast for buffing a blade. It gets it hot real quick, and these are one of the more dangerous machines in the shop. Mirror polishing a blade is a dangerous operation. These wheels, especially the soft wheels, can grab that knife out of your hand very quickly. And the faster they go, the more force they're going to throw that knife when one does get away from it. Another important tool is to have a drill press. Like most things, it's not absolutely necessary. You can take a hand drill and drill holes through your handles, but a drill press will just make sure you get them nice and straight. You got a good flat surface to lay something on, so you can drill perpendicular holes very precisely. Again, it's something you don't have to spend a lot of money on. This is a little bench model that I paid, you know, $150 for, and I've used it for probably 20 years. I would like to get a nice floor model someday, but actually I'm running out of floor space very quickly. A lot of my knives do have a guard, and when you're putting a guard over a full tang knife that's got pretty much a square rectangular tang, you need to cut a slot. And that can be done by drilling a series of holes and then just taking a file and connect the dots. and cut your slot. Much faster and easier and more precise way to do it is with a milling machine. Now the first thing I bought in that line was one of these all-purpose or multi-purpose machines. This is, Harbor Freight or Grizzly has things like this. It's a mill, a drill, and a lathe. I've got a milling and drilling head here that I can run up and down. Your vise and your table does adjust in and out. It's also got a lathe. Honestly, I bought this for $600 or $700. I've used it quite a bit. It does everything okay. It does nothing really well. It just leaves a lot to be desired as a mill or a lathe. And mainly because things just aren't real tight. These fixtures, no matter how you lock them down, when you're moving them around with your hand cranks, things will shift a little bit. And I see that on the lathe too. So if you really want precise work, these really are not the best thing. Also, there's two motors in this machine. There's one up here that runs the mill and the drilling head. There's a separate motor in the back that runs the lathe. This motor up here is encased in this cast iron with very, very little or virtually no ventilation. And I've burned out at least 3 of these motors. So it's just not well designed from that aspect. When I got tired of messing with this, I finally bought myself a really decent mill. Now, since I do a lot of knives that have guards and some other things where I need a good mill, I finally bought a good mill. This is a Wrong Fu sold by Inco, and it's a pretty decent machine. It's about a $1,500, $2,000 machine, but it's very precise. I can do a lot with it. Your tables go forward and back. Put a good mill vise on here, and I can do anything from cutting slots and guards very quickly, easily, and precisely, to cutting saw teeth and blades. Just a number of operations that this thing is just wonderful. And again, it's time and efficiency. You can cut a slot in a blade by drilling a series of holes, taking a hand file and connect the holes and make a slot. But with this, in 5 minutes I can cut a slot that all I need to do is take a square file and square up the ends of it. Now my shop is piled up even more than usual here lately. I had to move a lot of things around to try and make room to squeeze in my newest piece of equipment. This is a Decal Pantograph mill, and basically what it is has a small milling head right here, and it's a pantograph. Here's my stylus over here, and whatever the stylus does, your cutting head on your milling head does. So this is what people used to use exclusively for engraving, and in fact I can still do that. It does a very good job, where I can put a set of brass letters in here that are my template, and by following those grooves in the template with the stylus, this engraving tip over here will engrave those letters in whatever material I'm working with. I can also put an end mill in here instead of an engraving bit, and I have some templates where if I want to do an inlay in a handle, I can cut a perfect oval in that handle, and then I can take a piece of ivory or micarta or whatever I want my inlay to be and cut a perfect oval in that will fit perfectly in the one I cut in the handle. So it's a multi-purpose tool that does some really neat things. It is a pantograph. It has a ratio. I can reduce things anywhere from 1.5 to 1 to 10 to 1. And in other words, for my inlays, an oval inlay, my template might be a 3-inch wide oval. Well, if I set this to 3 to 1, it will cut a 1-inch wide oval in the handle. So it's a very versatile machine. I've wanted one of these for years. These are old German machines that just last forever. They are rather expensive. I happened to get a deal on this one, but normally they run $1,500, $2,000 if you can find them. And they're difficult to move. They're about 1,000 pounds, so they're tricky to move around and load and unload off a truck and get in your shop. But you know, this is just another thing that you don't need. You don't have to make knives, but if you want to take your game up to the next level and start doing some really unique stuff like inlays and engraving, you know, this will do it. Of course, nowadays you can get laser engravers and computerized 3D milling machines and stuff like that for $1,500, $2,500. Pretty much makes some of this stuff obsolete, but I just love these old machines myself. And speaking of mills, pantograph mills, and mills in general, I mean, in my opinion, the king of milling machines are the Bridgeport machines. But they're enormous machines. I don't think I could even fit one in my shop. I mean, if it's empty, I don't think I'd get it in the doorway. But they're fantastic machines. But, you know, if you find an old Bridgeport mill and you got room for it and you can afford it, they're wonderful to have in a knife shop. This is a little bending tool I bought from Harbor Freight. And if I need to take some flat bar and make some precise bends with it, I can use this. And you know, if I'm making a D guard or something like that, it'll let me make some pretty accurate bends with it. Just showing you around my shop a little bit. You know, this is my wood stock. I keep a lot of exotic woods from around the world in stock for handle materials, and these are some of my bigger pieces. You know, if I get raw wood that I've cut up myself, I'll let it lay here in the shop for a year or so and dry out good. You know, so it doesn't shrink up on me after I use it. But that's another consideration if you're setting up a wood shop, is you need room to put things and organize things. And you know, when you're crowded for room like I am, that can be a real challenge. You know, I have a main table that's kind of my catch-all. You know, I've got brass and nickel silver I use for guards. I've got blades in progress there. You know, I've got some stag and antler there. So, you know, I'm not the most organized by any means, but a lot of that's dictated by there's simply no place to put things. This is another unnecessary but handy little tool. I copied this off of my buddy Gil Hibben. He had one of these, so a friend of mine helped me make this one. And you see I've got a steel table here, and I've got a rather thick grinding or cut-off wheel here and a regular grinding wheel here. It's one of those things you don't use very often, but if you're putting a shoulder on a knife that the guard's going to sit up against or something like that where you need a good square shoulder, this works great for that. You can slide it up against the wheel either on the front edge or on the side, and you cut a nice square section on that knife. Again, it's one of those things I don't use very often, but when I do use it, you know, it's for 5 minutes and it does the job very precisely. And it's just one of those little kind of luxury tools. You know, I mentioned floor space. That is another important consideration. I'm working in, you know, an old 2-car garage, and you know, it's totally dedicated to knife making now, but I have got it packed full of my tools and equipment and a table to keep stuff, you know, blades in progress on, and pretty much I've just got a path that I can walk around here now. And there's some other equipment I would like to have, but you know, I'm really at the point where I have no place to put it. So that's another consideration when you're setting up, you know, to make knives, is as you grow and progress and get more equipment, you need more space. So that's a quick tour of my shop and basically the tools I have in here. You know, there's a couple of small things I didn't show you. I've got a set of torches if I need to solder guards on, or if I'm doing some non-stainless steel, you know, simple steel like 01 or 1095, I can heat it up with a torch and edge quench it. That is something else you need to consider if you're making knives. You will need to harden that blade, do your heat treating, and every steel has its own specific way that it needs to be done. Simple steel like 01 or you know, 1075, 1085, 1095, 52-100. Basically, these are simple steels. They're basically just iron and carbon. You heat them up to the point where they're non-magnetic, get them good and red hot, get them at that non-magnetic part, and then you quench them. Generally, you quench in oil. So they're rather simple to heat treat. When you get into stainless steels, you really need a temperature-controlled oven, because they have to go to a specific temperature and hold at that temperature for a specific amount of time. And then some of them are air hardening or air quench, where you just take them out of the oven, let them cool in the air, or sometimes you put them, some people put them between plates of steel to help keep them from warping while they cool. There are some tool steels like D2 that even though you need a temperature control oven to properly heat treat them, you also need to quench those in oil. So, you know, that's another thing. You know, a good heat treating oven probably run you $1,000, $1,500. Then you need to temper your knives after you heat treat them. You can do this with a conventional oven because you only need to go about 400 degrees. You know, if you have an understanding wife, sometimes you can get away with that, doing that with your kitchen range. Other people just buy a cheap old electric or gas oven to put out in their shop. I do heat treat mine in the house, in the kitchen, because I just simply don't have room to put an oven out here. A couple other things I could mention, like if you're doing Kydex sheaths, there's some special tools and stuff you might need with that. Cheap little toaster oven just for getting the material hot so you can form it. You know, you need good lighting. Over all of my tools, I have fluorescent lights directly over my bandsaw, over my mill, you know, just various things, and other things where I'm working real close I need to see. You know, I've got little clamp-on lights that can direct the light exactly where I'm working. But basically, you don't need a lot of tools to make a knife. You need very few tools. You can do it with a file. But these are the tools that I have collected over my 11 years of making knives that, you know, makes my life a lot easier, allows me to spend my time a bit more efficiently. You know, when you're trying to make some money making these knives, you just can't have 120 hours in a knife and sell it for a couple $100. You know, you can't do that. So, you know, when you're talking about efficiency, one thing I do is I work in batches of usually 6 or 8 knives at a time. And the reason I do that is I'll get all these 6 or 8 cut out, profiled, rough ground, ready to heat treat. Because heat treating is pretty much an all-day process. When you figure you take an hour or two to get the oven up to temperature, your knives are going to be in there for a half hour or so. Then you got to let them cool. Then they're going to go in the tempering oven for 2 to 4 hours. So you pretty much spend a day heat treating your knives. And it takes the same amount of time and the same amount of energy to do 6 or 8 knives as it does to do 1. So it just doesn't make sense to spend all that time and the utilities to heat treat 1 blade. When, if you got more to make, wait till you got 5 or 6 ready to go and do them all at once. So kind of recap, if you want to seriously get into knife making and get tooled up to do it in a pretty efficient way, the basic things you're going to need is a way to cut out your steel. You can do it with an angle grinder or hacksaw. Angle grinders are a little scary in my opinion. They're a little dangerous to work with. I invested in the metal cutting bandsaw. It's about $1,500, but to me it was money well spent. Then you need to grind your blade, and you can do that with a file. You can buy one of those little jet multi-tools for $300 or $400, but when you really get serious about it, you should really look at a good belt grinder. I'm a big fan of the Bader machines. They've worked very well for me. There's several other brands out there and types out there that you can buy or even build. A new Bader machine will run you about $1,500. There's 2 or 3 pieces that all seem to hit about $1,500 if you want to get serious about this. The milling machine, it's just making slots and doing things like that so much faster and easier, but again, the machine's about $1,500 again. You need a good drill press. You can get a low bench model pretty cheap. You need, I'd highly recommend a wood cutting bandsaw, because you can get them so cheap and find them really to be useful. Those are your main tools other than your heat treating. And as I said, a heat treating oven is going to run you somewhere between $1,000 to $2,000 depending on how big a machine you get. But there are people who will do heat treating for you, such as Peter's Heat Treating, where you can just send your blades out to them, and for a few bucks each they will do your heat treating for you. Or if you know of another knife maker in your area that happens to have an oven, you can usually work out a deal with somebody to get your heat treating done. If you don't want to invest in the heat treating oven. But those are your main components that you need. Everything else beyond that are just little things that kind of take you up another step, kind of like the Pantograph mill. It just adds a little more capability to my shop that the next guy might not have. That just a little something extra I can do with my knives, and there's lots of little things like that. So that's pretty much it, all I can think about. So if you're wanting to get into making knives, that's kind of your basic tour of my shop. Thanks for watching. It's Mike Carter, Carter Custom Knives.